A resistor is made of conducting materials, not insulators, but they have a resistivity to the flow of electrical current. It is used to control the current in a circuit to protect human beings and electronic equipments. We will be using this board where we have two resistors, 10 ohms and 33 ohms, and a light bulb. The two resistors would be connected in series and in parallel to see the equivalent resistance experimentally. And the light bulb also, we will change the frequency to see its behavior and the U versus the voltage versus current on Pasco interface. Pasco interface would change the current I and measures the corresponding or the according voltage. For example, هو already هون في voltage and current. If you connect the power to the first resistor اللي هو 10 ohms, okay, and we launch a recording, هو لحاله it will change the voltage and the current, okay, and you can stop it now and take some values and put the data on. As you can see, the first thing we see is that it passes through the origin. So if I equals 0, the voltage is 0. By taking the coordinates of the points over here, for example, فينا نعمل zoom maybe to make sure إنه our point is on the line. Okay, the first thing we notice is that the line is linear and passing through the origin, and this is a condition for Ohm's law, لأنه Ohm's law said that V equals R times I. Okay, so if we draw V versus I, the slope would be the resistance. Okay, if we change I, V would change accordingly, and since ما في plus شغلة, that's why it's passing through the origin. So let's write down the first value we get, 0.102 ampere and 1.014 volts. Let's take another point on the same graph, 0.08 ampere, 0.80 ampere, and 0.788 volts. Okay, you take the third and the fourth point. Okay, anyway, 33 ohms, هلا we can do the run again. We can record the and stop. Again, we take some points and we find. Okay, to be more accurate. Okay, this one is perfect. So we write it down, 0.033 ampere, 1.013 volts. Another point. So we can find some values in the negative part لأنه شو معناتها I negative, it only means إنه it's going in the opposite direction. The current بدل ما يعمل vibration in this direction بيعمل vibration in the other one. مثلا هون I can write it down إنه minus 0.016 ampere and minus 0.585. So we're always working with 10 ohms and 33 ohms. If we put them in parallel, in the series, 10 ohms and 33, okay, the equivalent, نعمل just the summation تبعها بتطلع 43 ohms. Let's do it experimentally. So هون already we know in the theoretical value should be 43. To do that experimentally, so we'll end from the battery to the first is a battery. هلا هون they are already connected as we explained earlier وهون الأوت. Okay, وما تنسوا V and I are changing using the Pasco interface. Now let's start recording the values and see the. Okay, stop. If we take some values, coordinates of a point. كمان it is a line passing through مش كتير the origin معناتها في عنا شوية error على السيستم. Okay, and let's note the first point هو 0.020 and the last zero is significant here. Okay, وعنا على الفولتج 0.757 volts. Okay, you write down. Okay, I will take the other measurements and will give you the data. Now, if we want to do it, the second experiment is when the resistors are in parallel, the equivalent will be اللي عنا 10 ohm, okay, و 33. Okay, to find the equivalent بدنا نعمل 1 over 10 plus 1 over 33 equal 1 over R equivalent. Okay, to find R equivalent, so he 33 plus 10 over 33 times 10. Okay, في step دايما تلاميذ بينسوها انه to find R equivalent I have to invert هودي. reciprocal حتطلع 330 over 43, which is around okay, you can find it, it is in on. Okay, let's start with the experimental part. هلا كيف بدنا نعملهم in parallel. In parallel يعني ال 10 وال 33 عندهم same point A والexit كمان هي same point B. اوكي هلا هون واضحه على البورد انه عندهم same point over here, but this one they are not attached او not connected. To do so فيكم تجيبوا حيلا واير اوكي وتقولوا انه هودي صاروا 1 point. when you connect بتعملوا اوكي بدل ما يكون قصير بقلب البورد اوكي لحول connecting wire. وصلنا هلا to connect الان على الباتري والاوت على other side. هلا I can put it whether here or here, مش فرقانة معي. And then I will delete and will start recording. Okay, let's take some. هو طالب منا طريقة البوينتس. For example هيدي 0.106 والفولتج 0.813 volt. Another point. If you change the current I and the resistance stays constant in the material, then the voltage would be proportional to that current. This is Ohm's law. Now, sometimes the resistance is not constant. It does depend on temperature, for example. If you change the temperature, the resistance would not be constant anymore. Then the relation between U and I is not linear. Frequency of the signal, it is around 0.3 hertz. 0.3 hertz is small frequency, okay? It means in 1 second, so 0.3 is what can cycle per second. So let's start recording the values. Okay, as expected, it's not linear. Now, if you focus on the points, عاملين شكل butterfly, okay? So بتطلع شيء وبنزل شيء تاني. If you look at the bulb, so عنا مثل cycle of the current is affecting the lightness of the bulb, okay? Let's take some points and prove no, it's not linear. To prove it's not linear, in math, for the same x, we have two different y's. In physics, for the same current, we have two voltages. And this can prove for anyone, إذا ما معه الصورة, the whole figure. Let's take some points. The two, إذا بدكم the more efficient points, هن for the same I have two different V. Okay? I will stop the power and let's take some points. هلا passing through the origin, yes it is, but no, it's not the efficient point. This one is efficient. For the same مثلا 0.126 ampere, okay, عندنا 0.335 volts. Let's write it down. So for the same current 0.126 ampere, أول point عندي إياه هو 0.335 volts. And the other one حأطلع vertically دغري فوقه بطريقة إنه also I will get 0.126 ampere. اوكي ما حلاقيه exactly هو ذاته. عندي 0.603 so 0.127 ampere. Okay, and the 0.6 volts. Now we will change the frequency. We will set it at 50 Hertz instead of 0.3 Hertz, which is a high frequency with respect to that one. Now the 50 Hertz is very fast in a way that the brightness of the lamp would not change a lot. It doesn't have the time to change, so as if it is always bright. So you can see the effect on the graph. The graph is flat and the butterfly effect has disappeared, and we can regain somehow the proportionality between V and I, the potential difference across the lamp and the current passing through that lamp.